Alright, let's talk about the DC power supply. This is a simple looking device with two channels, a channel 1 and channel 2. I both have them set to about the same voltage, but if you change one of them, look, I'm going to change this one to about 7.5 volts, switch over to channel 2, that doesn't change the second channel. They run at the same time, so both of these are outputting the displayed voltages even if the button is not pressed. Which is great for when you need different voltages out of each side at the same time. When you are working with your circuit, you should always make sure that this is turned off. You should always have your DC power supply turned off when you are making alterations to your circuit and you are not trying to actively measure things, as it is very easy for this thing to do damage. You can accidentally be drawing a bunch of current without realizing it, and then all of a sudden you're burning stuff on your breadboard and your instructor is trying to figure out where that smell of smoke is coming from. As well, once you turn this on, you should make sure that you keep an eye out for either of these lights turning on. If you see one of these lights turned on under overload, you need to turn it off immediately, or else it'll start to break something. That indicates that you have a bad connection. Something is connected directly to ground, causing you to have an incredible amount of current draw, and that's not good. Now, to get a positive voltage out of this and into your circuit, it's pretty simple. You connect a cable. It doesn't have to be a red one, but I just do this because it's helps with you to remember that this is your positive terminal connection. You connect the cable to the positive, one to the negative terminal, which in this case acts as your reference to ground. So this is going to be where your 0 volts is. And you connect it to your breadboard, which you can't see here, but I'm doing that. Turn this on, you'll see that I am supplying to my circuit 9 volts. I'm going to turn that up to 12, just because I like using 12 volts typically. And I'm going to set them both to 12, because that's what I prefer. And the reason why I'm fiddling with the second output channel for the DC power supply is because I'm going to show you how to get negative voltage out of the second output, which is important for almost anything you do with respect to with respect to a lot of things in this degree. You're going to be dealing a lot with transistors which require positive and negative voltage supplies, and all that means is that you have one output terminal or one output channel which is below the reference point. The reference point I'm referring to being ground or earth ground. This says basically that this right here, which is the connector to earth ground, we're basically saying that this right here is 0 volts, no matter what. Now, I connected the negative channel to the negative terminal to earth ground. That doesn't really do anything in and of itself right here, and current won't flow at all in the circuit because if I only have this guy connected and then I don't have ground on the board, obviously there's no connection, so current can't flow. I'll zoom out a little bit. Alright, cool. Now, what happens, if I can find my cables here, what happens when we connect the positive terminal of one of these output channels to the earth ground? Just like that. I have now said that this terminal right here is 0 volts because anything connected to ground is 0 volts. That turns this terminal right here, this negative terminal on channel 2, into negative 12 volts. I can get into the specifics of why that happens, but it's a little bit of a heavy discussion, and I'm going to try to keep this a little bit more basic. Feel free to do some more research on the topic if you're a little bit confused as to why exactly this happens. It's certainly confused me a bunch of times. But basically the best way that I like to think about it is thinking in terms of like altitude, right? So this is telling us where sea level is. This over here is above sea level because I've connected the end point here to 0. And now I've connected the start point here, or to sea level. Now I've connected the start point here to sea level, and now we are going below ground to -12. Okay. So we can take these and we can plug them into our breadboard, essentially, using the methods that I showed you before. And I'll go ahead and, well, I won't turn the camera down because everything's kind of a mess right now, which tends to happen as you start connecting more and more things. But if you want to, you can go back and reference the part where I was talking about the breadboard. You can see where I put my positive and my negative voltages into the cable holders. But I think next we will move on to the AC function generator, which I conveniently have above the DC power supply. I have them stacked only really here just so that you can, I'm going to turn this off, follow my own advice of keeping this off unless I'm measuring stuff. And you can see above the DC supply, I have this stacked only to make it easier for me to take a video of all of this. They shouldn't really normally be like this, it doesn't really hurt anything. And let's see if you guys can see that clearly, and you can. Let's zoom in a little bit more. And now you have a bunch of buttons on here. So this is the AC function generator. This is where you're going to get your signals, your AC signals from. You use your DC signals or your DC power supply to power your transistors and your amplifiers and your devices on your circuit. And you use the AC function generator to test signals as they go through your circuit. Now, I'm going to restart the video here because it's not very focused in very well. There we go, that's a little bit better. And there's a little bit to look at here. I'm going to go through the most important things because there's really a lot that you can do with this. I'm going to just go over, I think, how to set the frequency, the amplitude, and then I'll show you how to do or mess with the two different channels. As you can see, there are two outputs here, which are both very useful. And then I'm also going to talk about how to do a sweep, and everything else I think you can find out as you go through the classes, as there'll typically be instructions on how to do specific waveforms or bursts or more complicated things with the function generator. But for now, for basically doing some basic things, all we really need to talk about is the frequency, amplitude, and doing a sweep, and the two channels. So let's get right into it. Alright, so first things first, you'll see there's your signal is right here, and then this details your frequency, your amplitude. Your offset just indicates, let's see here, let's go to offset, just indicates how vertically offset your signal is, which you'll see in the oscilloscope. As you're measuring your channel outputs, the signal will start where that solid line is on the oscilloscope if it's referenced to ground. And don't worry about that one, the offset, too much. The phase changes where it starts. All right, as you can see, as you decrease the phase, it starts to kind of look a little bit more like an upside down cosine wave. Right, as you get to that to 90 degrees, I believe. But let's keep it at 0. Alright, so setting the frequency, you can do it one of two ways. You can hit the frequency and you can turn the dial, which will increase or decrease your frequency as you turn the dial. Of course, this can be a little bit tedious if you're trying to go from 10 hertz to 10 megahertz. The way you get around that is by simply pressing on the keypad once you've selected frequency. Enter in your value, and then you can choose from mega to kilo to hertz to millihertz to microhertz. Just select whatever multiplier you want, and there you go. See, 10 kilohertz. Pretty easy. Amplitude. Set the amplitude button. You can move the knob. You can again type in a value. I'm going to choose 200 millivolts, and that'll change that to whatever I've set it to. Now, we've set up channel 1. If we wanted to, we can go to channel 2 by pressing this button here on the bottom right corner, and that puts us into channel 2. And you'll know what channel you are because you'll kind of see these yellow borders, which signifies channel 1, and then channel 2 is signified by these the blue borders and the blue sine wave as well. See, yellow, blue. And this one is independent of the first one, so we can set this to whatever we want. That's separate of the other one. You see how it's saved the values that we set before. We can now look at the second channel, and it has completely different values. Of course, whatever we set it to. Maybe I can set it to 20 hertz, set the amplitude to 1 volt, right? And now you're not going to actually be producing any sort of signal from either of these channels unless you press the output buttons here on the right side above these output cables that you've hopefully put into your function generator by now. So you hit output, and that lights up. Hit output again, and the other one lights up. They're lit up because they're outputting a signal. Pretty basic. I can turn them off. And again, I would encourage you turning them off if you are not actively measuring things through your circuit. The worst, it's a little bit less dangerous to keep them running on the AC function generator. However, you can destroy these if your outputs are on and you make an accidental contact with, I don't know, say the outputs of the DC power supply, or maybe ground. You'll probably break something. So again, just be cautious with everything. Turn stuff off if you're not actively working with them, and just verify all of your connections as often as you can. All right, and lastly, I think we will move on to the oscilloscope. Oh, actually, no, we're not going to. I'm going to talk first, and lastly, what I'm going to talk about with using the function generator is the ability to do a sweep. Now, I don't see this used very often. It's a little bit more of an advanced thing, but it's not that hard to do. But it's very helpful if you are trying to measure across a range of frequencies. Maybe you're trying to test out your filter to see how good or bad the roll-off is over a period of time. So press sweep, and you'll see this line and the signal going through it. And the only things you need to really need to pay attention to is the sweep time. So this is how long the period, or how long it will take for the signal to run the sweep. Now I'm going to connect to the. I'm going to spoil the oscilloscope for you guys because I know we haven't gotten to it yet, but I'm going to just try to kind of show you how this sweep affects the signal being output. So we set the sweep time to 5 seconds. So over a course of 5 seconds, it is going to run from the start frequency to the stop frequency. We can set these to whatever we want. I'll set it to 500 hertz because maybe, I don't know, my cutoff frequency is 750 hertz. And I'll set my stop frequency to 1000 hertz, also known as 1 kilohertz. Now, that's really all you have to do. Everything else is already set up right here, where we set the frequency to 750, or well, let's see here. Yeah, we don't need to worry about that. We've already set up the amplitude to 200 millivolts peak to peak on the front page. The frequency, don't worry about the frequency because obviously it resets the frequency to whatever we have these values set to. So next, all I have to do is hit output, and I will move the camera a little bit so you can see what is going on over here. And you'll see that it is now sweeping over 5 seconds. See, ready? Let's do 1, 2, 3, 4, 5. About, there you go. Right, and then it resets from the start frequency to the start frequency. This is great for testing filters, as I said, because it really lets you see how the amplitude changes. How your output amplitude on your signal changes as you go through a sweep, right? Or as you increase or decrease your frequency. But nonetheless, that's how to do a sweep. Also thought it was important to just note and remind you all of the sweep, that the way that it works is that it is sweeping as long as it is in this menu and the output is on, okay? If you turn the output off, obviously it's not going to output anything. If you set your sweep and then hit sweep again so the sweep light isn't on, it goes back to parameter mode, which is just the solid, the normal, non-changing AC function output. So you just want to make sure that you're in the correct mode. Yeah, just want to make sure you're in the correct mode for what you're trying to do. So sweep off, sweep on, output off, output on, still sweeping here, not sweeping here. And those are all the basic functions of the AC function generator. I think we are safe now to try to move on to the oscilloscope and take a look at that and see how we can utilize that.